Hello calculus and welcome to 7.2. This is substitution. So we're going to be using a lot of u's in replace of the things as we work with them. After you get good at this, if you think you can do it without the u, you're welcome to, but please don't do it in this section. Maybe section 3, but you need to practice first. All right, so let's get moving. All right, we're going to use substitution to integration, which is a more complicated function. So like the functions are not near as pretty is what's going on here. So right here, these are some of your rules. And this one here is extremely weird, but important. In order to integrate, you have to have the original function and then the derivative of the function has to be beside it. All right, when you're multiplying. So I have to have the function and then du, the derivative of the function like we've done before. It just looks a lot different than it did before. And then we take the function to the n plus 1 power divided by n plus 1 plus c. We'll get through this. Okay, now when you do division, this time the derivative, the f prime of x, has to be in the numerator, so there's the derivative, and then we're dividing by the function this time. So this is like 1 over u, so it's the natural log of the function plus c is what we're looking for. Next, we're going to have an e to the f of x, which means you still have to multiply by f prime of x. You have to have the derivative of the function every time. So now it's eu, and then it's just plus c. All right, let's show you some examples. This is the first one. This is multiplication. And I rewrite these, so I put the derivatives together. So my function is this right here, 4x squared plus 8 to the 6th power, because that's what's in my parentheses. It has the power. That's what I need to worry about. The 8x and the dx represent the derivative. So here's my function. Here's my derivative. Now I have to make sure they match. If they do not match, I have to make them match, or you don't know how to do it yet. So when we go here, we have 4x squared plus 8. His derivative is 8x. Well, I have 8x directly, so I'm good to go. That means I just take the antiderivative of this part because I have the respect to x back here. So the antiderivative of that is u to the 7th, because you add 7, divide by 7. And now all I do here is replace my 4x squared plus 8 with my u plus c. All right, pause yours and try. All right, here your u is going to be 3x squared plus 4. That means my derivative of u is 6x. So when we rewrite this, we're going to put 3x squared plus 4. We're going to put the derivative together. And this matches what I need to have. So this means technically I have u du. So the derivative of that is u squared over 2 plus c. And then I need to take and replace the u with what it's worth. So that's 3x squared plus 4 quantity squared over 2 plus c. And that's the antiderivative using substitution. All right, now a little bit different here. This time, the u is 3x to the 4th plus 10. All right, that means, so if this is my u, my du is 12x cubed. All right, we need to rewrite this so it looks right. So I'm going to put the 12x cubed. I probably would have done this in a different order to make this a little clearer. Let's do this. We're going to rewrite it. We're going to put the 3x to the 4th plus 10 to the 1/2 power times my derivative, but I have x cubed dx. All right, my derivative needs a 12. So I have to put a 12 in here. But if I multiply by 12 here, I have to divide by 12 on the outside. All right, this way I have 1, because 12 divided by 12 is 1. I haven't changed my problem, but I still have the derivative that I need. All right, so I'm hoping you understand this and this right now. So what we truly have is u to the 1/2 du. Well, u to the 1/2, the derivative is u to the 3/2, well, that's divided by 3/2, but we know we can't divide by fractions, so we're going to multiply by 2/3, which gives us 2 over 36. I'm going to replace my u with what its value is, the 3x to the 4th plus 10 to the 3/2 plus c. And then all I'm going to do here is reduce the 2 over 36 to 1/18. All right, try yours. Okay, step 1, what's u? U is x cubed plus 9. So your derivative has to be 3x squared du. All right, let's rewrite this problem. So I'm going to put x cubed plus 9 to the 1/2 power, and I have x squared dx. But I need a 3. So if I put a 3 here, I have to have a 1/3 here. All right, I've got my 1. I have my derivative, so I'm good to go. So what I truly have is 1/3 times u to the 1/2 du. Okay, when we do the antiderivative, well, that's 1/3 from the outside, u to the 3/2 power, but I'm not going to divide by 3/2, I'm going to multiply by 2/3. So I didn't need that divisor there. Let's rewrite that pretty. Plus c. Okay, so now if I multiply here, that gives me 2/9. U is x cubed plus 9 to the 3/2 power plus c. All right, I hope you did a good job. Those are kind of fun, I think. At least not too bad. All right, let's move on. All right, now we got our division. There we go. It wasn't quite working. Here we go. Now we're going to do division. Now remember, we need the derivative on the top. So we need the f prime of x on the top. And we need the function on the bottom, dx. That's what we need in order to do the antiderivative. So this here has to be u, the denominator, which is x squared plus 6x. That means the antiderivative is 2x plus 6 dx. All right, I'm going to factor out a 2 here because I have to get to this x plus 3 in the numerator. So we're going to rewrite this. So now I've got, technically, let's do another step in here. We've got the integral. We've got 1 over x squared plus 6x. Now we're multiplying by x plus 3 dx. All right, this is where I need my antiderivative, or my derivative to be. I need a 2, so I got to multiply by 1/2 on the outside. Good to this point. So now what we have is du right here over u. Well, I know it's over u, that's a natural log. So now I've got the 1/2 from the front, the natural log of my u, absolute value, plus c. Replace u with what it's worth, and we are done. All right, give yours a shot. So your u is x squared minus 3x. Your du is 2x plus, minus 3 dx. All right, and it matches exact, so life is good. So currently you've got 1 over x squared minus 3x. My derivative back here is 2x minus 3 dx, and this matches exact, so I'm ready to go. So we have du over u. We know the derivative of that is the natural log, the absolute value of u plus c. Replace your u, whoops, that's an absolute value sign, with your x squared minus 3x plus your c, and you are finished. Okay, I hope you did a great job. All right, now it is e's. All right, here, let's rewrite this dude so we can see it. We've got e to the x to the fourth. It's terrible x. There we go. X to the fourth, and then I need my derivative back here. Well, the derivative of x to the fourth is 4x cubed. Whoops, I went too far. And then we got x cubed dx back here. All right, in order to get my derivative here, I know the derivative of x to the fourth is 4x cubed. So I need a 4. So we're going to multiply by 4 here and 1/4 here. That's how we came up with this. So now I've got my u du here. We know the derivative of e to the x to the fourth is itself, the 1/4 from here plus c, and we are done. All right, your turn. So your u is e to the hang on, I think I might have messed you up a little bit here. Yeah, hopefully this is written wrong here. Your u is just x to the fourth. Your du is 4x cubed. Sorry about that. So make sure you got that u out of there. It's right up here, but not in your notes. Okay, let's go to your Explorer. So your u is x cubed. Your du then is 3x squared dx. Okay, let's rewrite. We got ex cubed. And then we've got x squared dx. In order to match, we need to multiply by 3, which means we also must divide by 3 to keep our balance. Now when we do our integral, we're going to have the 1/3. We know that e to the x cubed is itself. So that's just e to the x cubed plus c. I hope you did a good job. Oh, I didn't use u here. I think you're still probably okay. All right, here we go. A team of researchers has determined that the marginal price of X boxes per week of nails is given by. So we're buying boxes of nails, and we have so much. Our marginal, right here, price is given by this. I want to know what the true price is, so not the average, how it's changing. So in order to do this, I have to do the antiderivative of my marginal. Well, now when I'm looking at this is a little difficult, and if I do 2 to the x plus 15 to the cubed as my u, we can, but there's really nothing up here. So we're going to move it up to the numerator. Cheating a little bit, but not bad. So now my u is 2x plus 15. My du is 2 dx. All right, when I look here, I technically have 2x plus 15, right? And this negative 4,000, I'm just going to get rid of for the moment. And I just have dx back here. Well, that means I need a 2 for my dx. Well, if I put my 2 in for my dx, then I have to divide by 2 out here, which is perfectly fine. This is how we came to this spot. So negative 4,000 divided by 2 is negative 2,000. Now I have my u to the negative third power, put that up here, times 2 dx. Now, so we got u to the negative third du. Well, the derivative of u to the negative third is u to the negative 2 divided by negative 2 plus c. So now negative 2,000 divided by negative 2 is 1,000. U to the negative 2 technically belongs in the denominator. And now we're going to replace it with what it is worth, which is the 2x plus 15. And that is your true price, not your marginal price. Now, I want to know what c is. I want to find an exact equation because right now it's not helpful. And I want to know what c is when p is 4, if p is 4 when x is 10. So we plug in the 4 for p, the 10 for x, and we just do our math. So we divide this out, we get approximately 0.82. We subtract it over, and it's approximately 3.18. So my equation for price is 1,000 over 2x plus 15 squared plus 3.18. All right, hope you did a good job. Next, marginal revenue. Same exact thing. So give it a try. Pause and try it. So we want to find R of x. So in order to find R of x, so our actual revenue, we have to integrate. And I'm going to rewrite this already. X squared plus 27,000 to the negative 2/3 power times 4x dx. Well, this 4 is in the way. So I'm going to take and move him to the front. All right, so my derivative, so if I got u equals x squared plus 2,700,000, then du is equal to 2x dx. So that means I need a 2 here, and I'm going to divide by 2 here. So currently we have 2 u to the negative 2/3 du. Well, the antiderivative of u to the negative 2/3, I should have given you more room. Let's go this way. So we got 2 times, oh, this is not near enough room. Sorry about this, guys. So you have negative 2/3, you can add 1, so that's u to the 1/3. We're not going to divide by 3. We're going to multiply by 3 over 1 instead of dividing by 1/3. So now we've got, just to help save me some room, plus c. So now we got 6 u to the 1/3 plus c. And we know that u is, so we're going to do 6 times x squared plus 27,000 plus c. Okay, we have the equation. And we go up to the 1/3 power. But we still have to plug in the 125 and the 29,591. I think I'll have enough room down here. So now we know that this is revenue, and our revenue is $29,591. So we go 29,591 has to equal 6 times 125 squared plus 27,000 to the 1/3 power plus c. And we're solving for c. So you're going to plug, I am out of room. You're going to plug all this in, and we're going to get, here, let's see if I can shorten this up. Okay, I plugged all this in at one time. So we have 29,591 equals roughly 209.59 because we're in dollars, so I just run it to 2 places, plus c. You're going to subtract that. So c equals 29,381.41. All right, so your new equation is R of x equals 6 times x squared plus 2,700,000 to the 1/3 power plus 29,381.41. All right, good luck on your homework. Post any questions if you have any.